Welcome back everybody to another video lecture. This is the second or third part, depending how we're using it this year, of the chemical bonding PowerPoint. And in this one, we're going to talk about covalent bonds, how to do Lewis dot structures, and about single, double, and triple bonds. So on this first slide, we need to talk about what is a covalent bond. Well, it's formed by a pair of shared electrons between two atoms. So what that means is that you're going to have one atom, let's just say carbon, sharing one atom, and then maybe like another atom sharing one. And then this is going to be a carbon hydrogen bond, and this line right here is representing two electrons. Hopefully you remember that we call a compound with a covalent bond a molecular compound, and then we'd say it's a molecule. And then this is important, you guys. Well, why do these bonds even form? The idea, if you remember with ionic bonds, is that they like to form the octet rule because that's most stable. What we're going to see is that these atoms will share electrons, and they'll form a specific bond length that matches up with the lowest potential energy. So if we look at this chart over here, we've got potential energy and we have bond length. So the atoms are really far away. They have really high potential energy. So that's what we're saying at number 1 here. And that means if they have high potential energy that they're less stable. At 2, they formed a bond, and it's like the perfect distance between the atoms. And what this means is we have less potential energy. You can see it's like lowest on the diagram. So this is where the atoms are going to be the most stable. Now, if the atoms get too close to each other, what we're going to see is that the potential energy really increases really high. And I always like to kind of make a joke or an analogy out of this. It's like a couple. Your relationship's a little unsure when you're really far apart. But if you guys are spending way too much time and texting each other every 5 seconds, you're going to have too much tension in the relationship. You need just the right distance or just the right bonding here to have a low potential energy and be in a stable relationship. Now on this slide, we just want to do a quick review of how to name the molecular compounds. So remember when we name them molecular compounds or molecules with covalent bonds, we're going to use the prefixes. We didn't use the prefixes for the ionic compounds because we were able to use those charges to determine the formula. So in this case, when we write the name, so if we see carbon, there's only one carbon here, so there's not going to be any prefix. We notice that there's 2 oxygens, so we're going to use the prefix dioxide. If we look at nitrogen, like N2O here, we can see that there's 2 nitrogens. So see, when we write the name, we wrote the di in the front. So if there's only one atom in the front for the first element, we don't use any prefixes. But if there is more than one, then we will use a prefix. Now notice in the second element here, oxygen, there's only one of them. So you might be like, well, we don't use a prefix then. No, it's actually kind of one of the wonky rules here is even if there's only one atom in the second element, you still have to use the prefix. So as you can see down here, I said, look at the first element. If there's only one atom of the element, I think I need to fix that, then don't use the prefix and just write the names of the element. If more than one atom, then add the prefix to the element's name. So you can see one atom, no prefix, more than one prefix. The second element always needs a prefix, even if there's only one atom, write the prefix and the element's name. And you can see like down here, only one nitrogen, so we're going to go nitrogen, but there's 3 hydrogens, so we're going to say trihydride. And then writing the formulas for these, I love writing formulas from covalent compounds because you really just need to look at the prefix and the element's name, the other prefix, and then that second element's name. So in this case, we've got pentaphosphorus decoxide. So like I said, look at the name and identify the element. So we can see from here it's phosphorus. Write the symbol for that element. So we know that phosphorus has a symbol of P. And if we look at the prefix, penta is equal to 5. So I'm going to write that subscript of 5. Then we're going to do the same thing for the second element. We can see that this is going to be oxygen. So we write the symbol for oxygen. And then it says decoxide. So remember deca, we just dropped that A there is equal to 10. So we're going to put a little subscript of 10 here. And then you're just going to write all the atoms together. So P5, O10 would be our pentaphosphorus decoxide. Now, hopefully you remember how to do the Lewis dot structures, and they're really important because what they can do is they can help us figure out how many bonds can each atom have, and that's going to be helpful. It'll be good clues when we go to write the Lewis dot diagrams. So go ahead, you know these: oxygen, carbon, nitrogen, fluorine, and neon. Take a second, write the Lewis dot structures, and then pause the video. Sorry, I should say pause the video, write the structures, and then come back and check your answers. So let's go ahead, check your Lewis dot structures. Hopefully they're matching up with mine. And now what I want to talk about is, well, when we make a bond, each atom needs to share a bond, okay? So when we look at oxygen, for example, right here, these guys are already paired up, so it's not going to form a bond. You can see up here, this lone pair, they're already paired, so they're not going to form a bond. So we're going to see oxygen's usually only going to form two bonds, either like this, or sometimes it'll just be a double bond with another atom. So if we look down here at carbon, carbon can have 4 bonds because it has 4 non-bonded pairs of electrons here. So we can see carbon with just a single bond, we can see carbon with a double bond, we can see it with a triple bond, and actually most recently, but very rarely, you can see it with a quadruple bond as well. This is just like newly discovered. So if you were to see it bonded like this, or bonded like this, or like this, so those are all the different ways that you might see carbon being bonded because it can make 4 separate bonds. Now let's look at nitrogen here. Nitrogen has a lone pair up here, but it's already bonded. So in this case, it would only form a bond here, and a bond here. So you're going to only see nitrogen forming 3 bonds. Then if we look at fluorine, everybody always messes up these halogens, so pay attention to it. Right now, we can see that this halogen has, these guys are already paired, these guys are paired, these guys are paired. So the only bond, so the halogens are only going to form the 1 bond possible. And then if we look at neon, we can see that neon is not going to make any bonding because it already has a full shell here.